In this lesson, we are going to focus on finding the area of a kite or a rhombus. So in order to find the area of a kite or a rhombus, what we're going to focus on is the diagonals. So if you remember, a diagonal goes from one corner across to the other, from one vertex to the other. So this is labeled as diagonal 2, and this is labeled as diagonal 1. We have the same thing going on in the kite. That's in a rhombus. Remember, 4 sides are congruent. And then in this one, we have diagonal 1 and diagonal 2. Now, just keep in mind for a rhombus, if you did have the base and the height, you could use that and treat that as a rectangle. Or not as a rectangle, as a parallelogram, excuse me. But if you have the diagonals, you can use the diagonals. So the formula is the area is equal to 1/2 diagonal 1 times diagonal 2, or diagonal 1 times diagonal 2 divided by 2. Whichever way you like to think of it, that's how you would find the area. So remember those qualities that we had for kites and rhombuses. So we know that we need to find the area of the kite or the rhombus. That means we need to know what our diagonals are. This kite has this diagonal, which is 56 plus 26. So you need to add those together because we need the entire diagonal, not just part of it. 56 plus 26, the entire diagonal is 82. So diagonal 1 is 82. And then we have diagonal 2 goes from corner to corner across that way is 20 plus 20. So diagonal 2 is 40. So to find the area, you would do diagonal 1, 82, times diagonal 2, 40, and then divide by 2. So 82 times 40 divided by 2 is 1,640 inches squared. Okay? Now remember, if I had just told you, right, now on this one I have it marked, but one of the qualities of being a rhombus is that the diagonals bisect each other. So you may know that it's a rhombus. I may tell you that it's a rhombus, but not tell you that the diagonals are congruent. That is something that you need to remember, or that the diagonals are bisected, not congruent to each other. So these are marked though, so this is 20 and this is 10. So diagonal 1 is 40 and diagonal 2 is 20. Now, just a side note, it does not matter which one is diagonal 1 and which one is diagonal 2. Okay, so it's just the first one I got to and the second one I got to. Area is equal to diagonal 1 times diagonal 2 divided by 2. So 40 times 20 divided by 2 is 400. So we have 400 square centimeters. Okay, now on a grid, we still want to follow the same thing, but we're going to have to count and find out how long our diagonals are. Now it's nice if your diagonals are on your vertical and horizontal because that makes it easy to count. Okay, so we're going to draw those in. Let's start with area since that's what we're working on. This one is 1, 2, 3, 4. So that's 2 and 2. And then this is 3 and 1, 2, 3, 4. I'm going to mark these like this because we're going to need them in just a second. So we have diagonal 1 is 4 and diagonal 2 is 3 plus 4, which is 7. So area is diagonal 1 times diagonal 2 divided by 2, or half of diagonal 1 times diagonal 2. 28 divided by 2 is 14. So the area of that kite is 14 units squared. Now, perimeter is a little bit trickier, right? And that's why I went ahead and drew these in so you can see this little right triangle right here. So we've got this right triangle right here, which doubles over here. And then I've got this right triangle down here. Just highlight it a little bit so you can see it. And they're both the same. So if we find this side, if we find WX, then we'll know XY. If we find YZ, then we'll know WZ. Well, how do we do that? That's a right triangle, so let's use Pythagorean theorem. A squared plus b squared is equal to c squared. Okay, c squared is your hypotenuse. So 2 squared plus 3 squared is 4 plus 9. It's the square root of 13 is 3.6. So c is equal to 3.61. And then we've got 2 and 4. So we have 2 squared plus 4 squared is equal to c squared. So the square root So you can see it, of 2 squared plus 4 squared is 4.47. So this length is 4.47. This length was 3.61. So to find the perimeter, you use double the 3.61 and double the 4.47. 4.47 times 2 plus 3.61 times 2, you get 16.16. So your perimeter is 16 and 1600ths units. Okay, that's the distance around that kite. Now on number 4, 4 is a little bit different because I actually gave you the area. So you want to write the formula. Area is equal to D1 times D2 over 2, or remember, you can use whichever one you want, D1, D2, like that. You can use whichever formula you want. Now substitute in the pieces that you know. So I'm just going to start. A is 126, so I'm going to replace that. I'm going to substitute that 126 in for the area is equal to D1. So I know one of the diagonals, but I don't know the other. So remember the diagonals all the way across, and remember that a kite, that short diagonal, the one that connects the vertex angles, or the non-vertex angles, that one gets bisected. So this one gets bisected, so that's 12 and 12. So diagonal 1 is 24. We don't know diagonal 2, which is BD. That's what we're trying to find. Okay, so we don't know BD. I'm going to call it X, and then that's divided by 2. Now right here, there's math you can do. Do all the math you can do. That's 24 divided by 2. So I have 126 is equal to 12x. Now, do the inverse, divide both sides by 12. You get 126 divided by 12 is 10.5. So the length of segment from B to D is 10.5. Okay, so area of a kite and a rhombus depends on the diagonals. So we can use the diagonals. Diagonal 1 times diagonal 2 divided by 2 gives us the area of a kite or a rhombus.